Hello guys, welcome to JEEmathstudy.com, where you can learn how to solve JEE mathematics problems. Okay, this is a quadratic equation problem which was asked in AIEEE 2002. It states, if alpha is not equal to beta but alpha square is equal to phi alpha minus 3 and beta square is equal to phi beta minus 3, then the equation whose roots are alpha upon beta and beta upon alpha is A or B or C or D. From the problem statement, we can clearly see there are two parts, first and second part. From the first part, we can derive some results which will help us solving the second part. So from the first part, we can clearly see that alpha is not equal to beta, alpha square is equal to phi alpha minus 3 and beta square is equal to phi beta minus 3. After rearranging them in a standard form, we will get this and this. From these two equations, you can clearly see that they have same coefficients, that is 1 1 here, minus 5 plus 3 plus 3. Hence we can conclude that alpha and beta are the roots of the equation x square minus 5x plus 3 equal to 0. If you want to know more about the concept of roots of quadratic equation, you should check out the link in the description. Okay. From the previous slide, we know alpha is not equal to beta and alpha and beta are the roots of the equation x square minus 5x plus 3 equal to 0. Now, we know that any quadratic equation can be written in standard form as ax square plus bx plus c equal to 0, which can also be written as x square minus sum of roots into x plus product of roots equal to 0. That is, if you know the roots and if you find the sum of roots and product of roots, by substituting these values in this equation standard form, you can get back the quadratic equation. Now rearranging this standard form in following manner, just by dividing both sides by a and taking minus sign common here, where a, b, c are the coefficients. You can clearly see that both these equations are similar. Hence you can say the sum of roots can be written as minus b by a and product of roots can be written as c by a. Remember these three results, which are very useful, and if you want to know more about this, you should check out the link in the description. Now, applying these two results to our quadratic equation, that is x square minus 5x plus 3 equal to 0, where alpha and beta are the roots, we can get the sum of roots as alpha plus beta equal to minus b by a, that is substituting value of coefficients, b as minus 5, a as 1, will get phi, and alpha beta as c by a, that is 3. Now we got another two results, that is alpha plus beta is equal to phi and alpha beta equal to 3. These are the two results which we derived from the first part of the problem statement. Now we will use these two results to find this solution in the second part. In the second part, we need to find out equation whose roots are alpha upon beta and beta upon alpha. We know the roots, then we can find out their sum and their product. If we know the sum of roots and product of roots, then we can get back the original quadratic equation. Let's find the sum of roots. That is alpha upon beta plus beta upon alpha, which will give us alpha square plus beta square upon alpha beta. Alpha beta we already know, that is 3. Now we need to manipulate alpha square plus beta square in terms of alpha plus beta and alpha beta. We can do this in this manner. This is the only trick in the problem. Everything else is mechanical. Now substituting the value of alpha plus beta and alpha beta, we'll get sum of roots as 19 by 3. Now product of roots is pretty much straightforward. Alpha beta upon alpha beta, which will give us 1. From the previous slide we know sum of roots and product of roots. Now substituting these two values in this equation, we will get x square minus 19 by 3 into x plus 1 equal to 0. Multiplying both sides by 3, we will get 3x square minus 19x plus 3 equal to 0, which is same as D. Hence D is the correct answer. If you like this video and find it useful, please share and subscribe. Thank you.